Hi everyone, so here's a series of videos to help assign RRS for asymmetric centers. So starting off with problem 1, we're going to assign RNS to the asymmetric center in the compound below. So I always tell my students that before you ever go through and start assigning priorities is to double check to make sure that the atom is actually asymmetric. So if we look at this, we know that we have 3 hydrogens on this carbon here, so that will not be asymmetric. Here, we do have an asymmetric center, so we know that we have a hydrogen. Something I keep seeing students are doing is they try to put the hydrogen down here. Don't do that because it will, if you have to do double flip, it is going to mess up your assignment. So remember when we talked about skeletal structures and Newman's, that dashes and wedges always have to be side by side. All right, so if the wedge is on top of the structure like it is here, then the dash should also be on top right next to it, okay? Don't forget that. And then, so if we look at this carbon, we see it has a bromine, it has a hydrogen, it has a methyl group, but we can say carbon, but we also have another carbon here. I don't have a difference in priority between 2 carbons, so I need to keep looking. And that's where I compare the idea that I have 3 hydrogens on this carbon here, whereas this carbon has 1 hydrogen, and then it is double bonded to another carbon. So I pretend that it actually has 2 single bonds to carbon, and that is how I account for the double bond. Now I have a difference, or a point of difference between these two, and the group that has more higher priority items is going to be highest priority, so this will be higher priority compared to this one. So yes, I have 4 different things here because those carbons are not identical, so this is asymmetric. And then the rest of my carbons are involved in a double bond, and the definition of asymmetric is I have to have 4 different groups. Well, if we're in a double bond, by default, there's only going to be 3, so a double bond or sp2 hybridized atom will never be asymmetric. Same goes for sp as well. All right, so now we figured out that we do have an asymmetric center. Let's go ahead and work through the assignment. So to assign priority, we're going to use the same priority rules that we do for EZ, meaning the higher the atomic number, the higher the priority of the group. So bromine is going to have the highest priority, so it will be my 1 position. All right, hydrogen is going to be the lowest. And then we already talked about the idea that this side is higher priority than this side because it has more higher priority groups or items. All right, so that's the first thing, is assign my priorities after I've checked that I have an asymmetric center. Then I'm going to check to make sure that my lowest priority group is in the back. All right, what does that mean? Well, if it's in the back, that means it's coming away from me. So I want to have my lowest priority groups on a dash. And in this case, I already have it on the dash. That hydrogen is on the dash here, so I'm good. I don't have to do anything else to the structure. Now what I'm going to do is trace a circle from 1 to 2 to 3. I do not include 4 in that. Why? 4 just tells me if my compound is in the right perspective or position to look at it. We've already confirmed that this compound is in the right perspective because 4 was in the back. That is its job. It has nothing to do with clockwise or counterclockwise. 4 just tells you, am I in the back, yes or no? If the answer is yes, we're good. If no, we're going to talk about that in the next video, I think, or video 3. That's it. So if I only care about 1, 2, 3, I'm going to draw my circle. So I go from 1 to 2 to 3. I am going clockwise, so this should be R. All right.